Hi, I'm Janet Stramel, and this is Integrating the 8 Standards for Mathematical Practice into Your Daily Lessons. This is Part 2. Last week I covered Standards 1, 2, 3, and 6. So this week we'll do Standards 4, 5, 7, and 8. Just a little bit about me. I'm an associate professor at Fort Hays State University in Hays, Kansas. Hays is in western Kansas, about 5 hours from Denver. I teach for the education department, mathematics methods for elementary education majors, and then I also teach a couple of classes for the mathematics department and particularly the concepts of elementary mathematics course. I am a national board certified teacher in early adolescence mathematics. And before I came to Fort Hays State University, I was a middle school mathematics teacher in both Oklahoma and in Kansas. And my email address there is if you ever would like to contact me. So as I said, today's session is about 4 of the standards for mathematical practice. They reflect what it means to actually do mathematics. No matter what your objectives are, your textbook, your grade level, the 8 standards for mathematical practice are a guide to good mathematics instruction. So this session will give you some suggestions for incorporating them into your everyday mathematics instruction. And again, Part 2, today we're going to cover the practices 4, 5, 7, and 8. When you read the standards for mathematical practice, notice that each one begins with mathematically proficient students. Also, notice how the standards are completely student-centered. Instead of teacher-led instruction for the majority of a class period, we as teachers should facilitate meaningful discussions in our classrooms and allow our students to drive the conversations. We want to motivate our students to attack each task from their own angle. We want to allow our students to explore, discuss, and disagree with one another. They might fail, they might succeed, and they might fail some more. But in the end, the vast majority of your class, your students, will become mathematically proficient. Also, notice what the standards do not say. The standards are not about listening while the teacher provides direct instruction. The standards for mathematical practice are not about just copying notes word for word from the board. They're not about memorizing a set of rules or procedures for solving problems. And they're not about our students sitting quietly throughout the lesson without any peer interaction. Bill McCollum, one of the lead writers of the Common Core State Standards, grouped the mathematical practices in this order. So that's why last week we did Standards 1 and 6, the overarching habits of mind, and 2 and 3, reasoning and explaining. Many of the processes and proficiencies in the individual practice standards do overlap, and several can be used together in solving a problem or engaging in a task. Most of the practices can be applied to most of the content standards. And Bill McCollum said that in order to avoid doing nothing when integrating the practice and content standards, that's why he grouped these to bring a higher order of structure. So let's start with standard number 4. 4 and 5 is about modeling and using tools. One intent of this standard, number 4, is to ensure that children see, even at the earliest ages, that mathematics is not just a collection of skills that the only use is to demonstrate that one has those skills. Even puzzles can meet that goal. Another intent of this standard model with mathematics is to ensure that the mathematics that students engage in helps them see and interpret the world, the physical world, the mathematical world, and the world of their imagination through a mathematical lens. One way, as mentioned in the standard, is through the use of simplifying assumptions and approximations. Children typically find estimation pointless and sometimes even confusing when they can just get the exact answers. But many mathematical situations do not provide the information needed for an exact calculation. Practice number 4 states, mathematically proficient students can apply mathematics to solve problems in everyday life. They might describe a situation, for example, an equation, a diagram, a graph, or a formula. They are able to simplify a complex problem and identify important quantities to look at relationships. They make sense of results and improve their models as needed. Students use models to represent and solve a problem and translate the solution to mathematical symbols. They can also accurately explain the solution representation and use a variety of models, symbolic representations, or technology tools to demonstrate a problem. Mathematically proficient students who can apply what they know are comfortable making assumptions and approximations to simplify a complicated situation, realizing that they might need to revise later. They're able to identify important quantities in a practical situation and map their relationships using, again, diagrams, two-way tables, graphs, flowcharts, and even formulas. They can analyze those relationships mathematically, and then they're able to draw conclusions. They routinely interpret their mathematical results in the context of the situation and reflect on whether those results make sense, possibly improving that model if need be. My first bullet, math limited to math class is worthless. Our students tend to compartmentalize things. You only do math in math class and you only do science during science time. But we should have our students use mathematics in science, art, music, reading. Any content area has a math connection. We also want to use real graphics, real data, real articles to make math more relevant and to make it real. And we want our students too to have to be able to create real-world problems using their own mathematical knowledge. Mathematically proficient students can apply the mathematics they know to solve problems arising in everyday life, society, and the workplace. So in the early grades, this might be as simple as just writing an addition equation to describe a particular situation. In middle school, a student might apply proportional reasoning to plan a school event, or maybe analyze a problem in their community. And by high school, students would be able to use geometry to solve a design problem, or use a function to describe how one quantity of interest depends on the other. As teachers, when we want our students to model with mathematics, we want to use mathematical tools that are appropriate for our focus of the lesson. We want to encourage our students to use developmentally and content-appropriate mathematical models, such as variables, equations, coordinate grids. And we want to remind our students that a mathematical model used to represent a problem solution is in fact a work in progress and can be revised as needed, just as in the real world. And for our students, we want them to apply their prior knowledge to solve real-world problems. We want our students to identify important quantities and map their relationship using tools, again, like diagrams, two-way tables, graphs, flowcharts, formulas. We want our students to use assumptions and approximations to make the problem simpler, and they should always check to see if their answer makes sense within the context of the situation. So I really like the Illustrative Mathematics website. It's just illustrativemathematics.org, and you can go there to find many sample tasks that relate to each of the 8 standards for mathematical practice. So this is just one that I've pulled for today to illustrate meeting Standard 4. In elementary school, students begin to think about how numbers and operations can describe the world. Deciding which operation applies to a particular context and why is an important step toward being able to do increasingly more sophisticated modeling problems in later grades. So this problem, analyzing word problems involving multiplication, the purpose of this task is for students to analyze different contexts in which multiplication is appropriate. Research indicates that students often do not make sense of word problems. Instead, to come up with an answer, they just apply the most recent algorithm taught, choose operations based on the types of numbers involved, or they apply other approaches that do not require sense-making. So in this task, the students are asked to analyze the problems and explain their thinking before they find an answer. So in that process, they're thinking more carefully about different contexts that can be represented by multiplication. Note that none of these contexts involve multiplicative comparisons. That's intentionally left until 4th grade. Another task that I chose from the Illustrative Mathematics website is this one that you see on the screen. It's for 7th grade. In order to model with mathematics, students need to make simplifying assumptions about a context. It is important for students to have opportunities to do this in very familiar context before they're asked to do a more complex task of making those assumptions for unfamiliar or scientifically complex context, as they will be asked to do in high school. So again, this is a 7th grade lesson. It's called RP SAIL. The standards for mathematical practice focus on the nature of the learning experience by attending to the thinking processes and habits of mind that students need to develop in order to attain a deep and flexible understanding of mathematics. So you can read on the screen that the problem says 4 different stores are having a sale. The signs below show the discounts available at each of the 4 stores. And then the 2 questions at the bottom, which of these 4 different offers gives the biggest price reduction, and explain your reasoning clearly, and which of the 4 different offers gives the smallest price reduction, and again, explain your reasoning clearly. For example, if the items that are purchased do not have the same value, then the price reduction depends on the cost of the items. The answer also depends on how you interpret the meaning of price reduction, which could either be absolute reduction or the relative reduction. Again, this is a 7th grade problem. As teachers, in order to elicit deep mathematical thinking, we might want to ask our students questions like these. What number model could you construct to represent the problem? What are some ways to represent the quantities? What's an equation or an expression that matches the diagram or the number line, the chart, the table? Where did you see one of the quantities in the task in your equation or expression? Would it help to create a diagram, a graph, or a table? What are some ways to visually represent, and you can fill in the blank, or what formula might apply in this situation? Moving on to Mathematical Practice 5, use appropriate tools strategically. Practice number 5 is essential, and it's easily overlooked. It is the call for students to develop the ability to make sound decisions about when each of these tools might be helpful, recognizing both the insight to be gained and their limitations. This requires that students gain sufficient competence with the tools to recognize the differential power they offer. It also requires that student learning include opportunities to decide for themselves which tool serves them best. It also requires curricula and teaching to include the kinds of problems that genuinely favor different tools. It may also require that from time to time a particular tool is prescribed or proscribed until students develop a competency that would allow them to make sound decisions about which tool is best. Practice number 5 states, mathematically proficient students consider, then choose appropriate tools to solve a problem. Their choices could be paper and pencil. They could be some concrete materials, a calculator, a spreadsheet, software. Students need to be aware of the strengths and limitations of various tools. They are able to use technological tools to explore and deepen their understanding of the concepts. Students should be able to select from a variety of tools the ones that can be used to solve a problem, and they need to be able to explain their reasoning for the selection. For practice number 5, I strongly encourage you to not tell your students which tool to use. And try to leave that decision open-ended, and then ask your students what worked best and why. For example, if I wanted my students to find their height, I would provide measuring tapes, rulers, meter sticks, any mathematical tool. Then once everyone found their height, then we could discuss which worked best and why. Maybe that 6-inch ruler is not the best tool for someone that's 6 feet tall. And leave math tools accessible and resist the urge to tell your students which tool they need for which task. Let them decide, and I put on the slide, as you can see, they will surprise you. In elementary school, students are provided tasks that require a variety of tools to solve, and then in high school, tasks might include your students analyzing graphs of functions and solutions, that are generated by a graphing calculator so that they can detect possible errors. They're using estimation and other mathematical knowledge. So as teachers, we should provide a variety of tools again and technology for our students to explore and deepen their understanding of the mathematical concepts. We want to help our students make sound decisions regarding the use of specific tools appropriate for their grade level and the content focus of their lesson. And we want to provide problem-solving tasks that require students to consider which tool to use. Do they want paper pencil, or a concrete model, or a ruler, or a protractor, a calculator, a spreadsheet, some computer algebra system, or dynamic geometry software? And for our students to meet practice number 5, use appropriate tools strategically, we want our students to consider available tools when solving a mathematical problem. We want them to become familiar with the variety of mathematical tools and to use them when it's appropriate to explore and deepen their understanding of concepts, and to make sound decisions about the use of specific tools. We also want our students to use those technological tools to visualize the results of their assumptions, explore the consequences, and compare predictions when using data. They also should identify the relevant external math resources, such as digital content on a website, and use them to pose problems or solve problems. So my example that I have here, I found this at Sadlier Math, S-A-D-L-I-E-R, sadlier.com. There's so many appropriate tools and good tools out there. So it's simple to say, or it could be simple, to say that this standard is about using a compass or a protractor, a ruler, but it's so much more about that than just the physical objects. Even extremely simple tools are the product of a long period of experimentation, experience, observation, reflection, and recollection. By giving students choices and talking to them about why they chose a specific tool, you can help them grow in their choice of strategies and help them reason mathematically and justify their answers. The physical tools. Teachers use many tools in their classrooms, but the focus of this standard is not only tools. It's encouraging our students to choose between the tools and discuss why they chose that and could use that. This is the objective behind the Standards for Mathematical Practice number 5, developing in students the ability to reason, which in this case is about using tools to investigate and solve problems. One way to help students use appropriate tools is by teaching them about geometric transformations. When you work with your students on using different tools to experiment and solve problems with transformations, you could use transparencies or tracing paper to copy the figures, cardstock to cut out the figures, coordinate grids for graphing the figures, and a compass and a straight edge with a blank sheet of paper to redraw the figures. It is an investment of time to teach students to use these tools, but as a result, when students are faced with new problems, then they have that wealth of tools to use. In addition, you can have rich discussions with your students about how to use appropriate tools strategically. Another example I found from the elementary grades could be when students need to estimate the sum of two-digit numbers. Some tools that might be available in this case would be a number line, a hundreds grid, paper pencil, various types of counters, perhaps even a calculator. These tools or these objects are all valid tools. Giving your students a choice of those materials and then having that discussion again leads to meeting this practice number 5 of using appropriate tools strategically. Another example, when you're using number bonds, that's a cognitive tool or representation. It helps students understand the relationships of parts and wholes through the operations of addition and subtraction. The number bond is a durable mental model or tool that can be used with students and is revisited through the elementary and middle school grades. It can be used with whole numbers, fractions, decimals, integers, and even rational numbers. Students can apply this tool, the number bond, to organize information from word problems and to form an equation to solve the problem. So that's just one way that students can use appropriate tools strategically, even when the tools are cognitive in nature. Also, don't forget the National Library of Virtual Manipulatives, and don't forget the Desmos Graphing Calculator. National Library of Virtual Manipulatives and Desmos Graphing Calculator. Again, I have some questions to consider and to develop as you want your students to meet practice number 5. You could ask your students, what mathematical tools could we use to visualize or represent the situation? What information do you have? What do you know that's not stated in the problem? What approach are you considering first? What estimate did you make for the solution? In this situation, would it be helpful to use a graph? Maybe you want to use a number line or a ruler or insert another tool. Why was it helpful to use that diagram? And in what situations might it be more informative or helpful to use a ruler? And you could fill in the blank. Moving on to Standards 7 and 8, these two practices relate to seeing mathematical structure and generalizing. Practice number 7, mathematically proficient students look closely for pattern or structure. They can step back and look for an overview and can shift perspectives. Students look for structure within mathematics to help them solve problems efficiently. For example, 2 times 7 times 5 has the same value as 2 times 5 times 7, so instead of multiplying 2 times 7, 14, times 5, then they could mentally do 2 times 5, 10, times 7. In order for our students to look for and make use of structure, we want to help our students identify multiple strategies and then select the best strategy. We want our students to repeatedly break apart numbers and problems into different parts. They should use what they know is true to solve a new problem. And we want our students to prove their solutions without relying on the algorithm. For example, when students are changing mixed numbers into fractions, they have to prove to you that they have the right answer without using steps. And I would challenge you to do that for yourself. We're so stuck sometimes, I am, to the rule of how to change a mixed number to a fraction. Can you explain that without using the steps? Students We'll also be able to compose and decompose number situations and relationships through observed patterns in order to simplify solutions and see complex and complicated mathematical expressions as component parts. Mathematically proficient students look closely to discern a pattern or structure. Young students, for example, might notice that 3 and 7 more is the same as 7 and 3 more. Or they might sort a collection of shapes according to how many sides the shapes have. And then later, they'll see that 7 times 8 is the well-remembered 7 times 5 plus 7 times 3. And that is in preparation for learning about the distributive property. Students recognize the significance of an existing line in a geometric figure, and they use the strategy of drawing an auxiliary line for solving problems. They can also step back for an overview and shift their perspective. Students can see complicated things, such as some algebraic expressions, as single objects or as being composed of several objects. So you can see my example there, 5 minus 3 times x minus 2 to the second power. They see that as 5 minus a positive number times a square, and use that to realize that its value cannot be more than 5 for the real numbers x and y. As teachers, to encourage our students to look for and make use of structure, we want to provide opportunities and time for our students to explore patterns and relationships to solve problems. We want to provide our students with rich tasks and facilitate pattern seeking and understanding of relationships in numbers rather than following, again, that set step of patterns, rules, or procedures. We want to engage our students in discussions emphasizing relationships between particular topics within a content domain or across domains. We want to recognize that quantitative relationships modeled by operations and their properties remain important regardless of the focus of the lesson, the operational focus of the lesson. And we want to provide activities for our students to demonstrate their flexibility in representing mathematics in a number of ways. Again, for example, 76 is 7 times 10 plus 6. For our students, we want them to look closely to discern patterns or structure. We want our students to associate patterns with properties of operations and their relationships. We want our students to step back for an overview, and then they may need to shift their perspective. Students should see complicated things, such as an algebraic expression, as a single object or composed of several objects. So for young children, this would be either decomposing or composing numbers. We want our students to look for patterns or structure, recognizing that quantities can be represented in different ways. And we want our students to recognize the significance in concepts and models and use patterns or structure for solving related problems. This sample task comes from Gail Burrell, and if you don't follow her on Twitter, I would suggest you follow her. She always has some really interesting things that she tweets about. So she said to solve for x, and you can see that it's 3 times the quantity, x minus 2 equals 9. So then rather approach the problem above by distributing, like we probably have always done, or dividing. A student who uses structure would identify that the equation is saying 3 times something is 9, so therefore what's in the parentheses has to be 3. 3 times 3 is 9. And then you can see the bottom one, solve for x. So a typical approach would be to cross multiply and solve. But your students who are identifying and making use of structure, they can see that the left side can be multiplied by 2 to create those equivalent numerators, and then they simply set the denominators equal and solve. Also, Inside Mathematics has video examples of practice number 7, and you can watch this in action in 4th and 5th grade classrooms. Inside Mathematics, and just look for practice number 7. Also, I found Think Math has a good discussion about practice number 7. Questions that you would want to develop, questions that you would want to ask your students to develop mathematical thinking could include, what observations did you make about, insert. What do you notice? What parts of the problem could you eliminate or simplify? What patterns do you see? How do you know if something is a pattern? What ideas that we've already learned could be useful in solving this problem? Are there some other problems that are similar to this one? And in what ways does this problem connect to other mathematical concepts? Practice number 8, look for and express regularity in repeated reasoning. Mathematically proficient students see repeated calculations and look for shortcuts. As they work to solve a problem, they maintain oversight of the process while attending to the details. They continually evaluate the reasonableness of their results. Students will look for obvious patterns and use the if-then reasoning strategies for obvious patterns, be able to find and explain subtle patterns, and discover deep underlying relationships. Mathematically proficient students notice if calculations are repeated and look both for general methods and for shortcuts. As they work to solve a problem, mathematically proficient students maintain oversight of the process while attending to the details. They continually evaluate the reasonableness of their intermediate results. Practice number 8, look for and express regularity in repeated reasoning. We want to show our students how the problem works, and as soon as they get it, ask your students to generalize to a variety of problems. And I would encourage you, do not ask your students to work 50 or 30 or of the same problem. Take your mathematical reasoning and apply it to other situations. I liked what Greg Tang said about this standard. He said to show students how the problem works. As soon as they get it, start generalizing. You can see that bullet on my slide. Mathematically proficient students notice if calculations are repeated, and they look for both general methods and shortcuts. Elementary students solve problems and notice when dividing 25 by 11 that they are repeating the same calculations over and over, and they can conclude that they have a repeating decimal. By paying attention to the calculation of slope, as students repeatedly check whether points on the line through 1, 2 with a slope of 3. Middle school students might abstract the equation. They notice regularity in the way terms cancel, and it could lead them to a general formula for the sum of a geometric series. As teachers, we want to provide problem situations that allow our students to explore regularity and repeated reasoning. We want to provide rich tasks that encourage students to use repeated reasoning to form generalizations, and we want to provide opportunities for our students to communicate these. We want to engage our students in discussion related to repeated reasoning that may occur in a problem solution. We want to draw attention to the prerequisite steps necessary to consider when solving a problem, and we want to urge our students to continually evaluate the reasonableness of their results. For our students, we want them to notice if their calculations are repeated and to look for both general methods and shortcuts. We want them to pay attention to the regularity and to use that to solve problems. We want them to use regularity and use that to lead to a general formula and a generalization. We want our students to maintain oversight of the process of solving a problem while attending to the details, and then continually evaluate the reasonableness of their results. Again, we want our students to notice repeated calculations and look for a general method and even a shortcut. But we don't want to teach that shortcut up front. And we want our students to continually evaluate the reasonableness of their results, attend to details, and make generalizations of their findings. There are a lot of sample tasks from the Illustrative Mathematics website related to practice number 8. So I've chosen a few here to share with you. There are also vignettes and videos on the Illustrative Mathematics website for you to look at. I want to share with you one that's called Adding Multiples. This task is appropriate for assessing students' understanding of repeated reasoning and generalizing that understanding to prepare them for deeper algebraic thinking needed in expressions and equations. It allows the teacher to assess the level of understanding by analyzing how they solve the problem, whether it's algebraically, concretely with picture representations, or both. Students who solved a problem more concretely may benefit from your guidance as the teacher in order to find a general algebraic solution. The standards for mathematical practice focus on the nature of the learning experiences by attending to the thinking processes and habits of mind that students need to develop in order to attain a deep and flexible understanding of mathematics. So this task that I chose for number 8, look for and express regularity in repeated reasoning, is from 8th grade. Oh, I'm sorry, 6th grade. I'm sorry about that. And you can see Nina was finding multiples of 6. She said 18 and 42 are both multiples of 6. And when I add them, I also get a multiple of 6. Explain to Nina why adding 2 multiples of 6 will result in another multiple of 6. questions that you can ask your students to develop mathematical thinking as related to practice number 8. Will this same strategy work in other situations? Is it always true? Is it sometimes true or never true? And use evidence to explain. How would we prove? Or what did you notice? Is there a mathematical rule? And explain that rule to me. What would happen if? Or what predictions or generalizations can this pattern that you've explained to me support? And what mathematical consistencies do you notice? Again, I would suggest that you go to the Illustrative Mathematics site. Just look for the practice standards, and you can see down the side there are the 8 standards for mathematical practice. This is an amazing site for you to access. Another website that I wanted to share with you is mathshell.org. You can see on the side menu the standards for mathematical practice. And then you can click on that, and then you will come up with all these different problem sets or tasks that will give you a good lesson that relates to one of these standards for mathematical practice. Some other resources that I want to share with you. One thing we've done in Kansas is called the Flip Books. It's grades kindergarten through grade 12, and there is a wealth of information not only related to the mathematical practices, but also to the Common Core standards. And even if you're not a Common Core state, there are good resources there for you to use. Just Kansas Flip Books. If you don't follow Bill McCollum, his blog is always interesting to read. And then be sure and check out Jo Boaler's U Cubed site. She always has some good problems too. Debbie Wagner has a lot of information about the standards for mathematical practice on her site. And then again, Inside Mathematics is where I found a lot of the resources that I use today. Thank you very much for your attention. If you have any questions, just let me know, and you can always email me at jkstramel@fhsu.edu. Thank you very much.